and we can start making our features. Now, we can choose what order we do this in. We could either do all the drilling from the front first, then make the other features. We can make the steps first, and then the pocket, and then drill the holes. I would suggest that we go ahead and make the steps first, because if you look at our drawing, we have a very tight tolerances, plus or minus 4 on the thicknesses. So if we cut this very first step, which will be on the edge of the vise, and we cut all 3 of these with the same cutter, they should come in relationship to each other the same. So what we'd want to do is stop our program and measure this with a micrometer, and if it's at the beginning of the program, we can stop it, measure with the mic, and see if we need to make any adjustments in Z to hit our tolerance. Just gives you the opportunity that if we do all the other machining, we have committed ourselves to cutting all the parts, and then you come back at the end and check that height. So if we're doing design for inspection, that's what I would do first. Okay, so we have 1, 2, 3 levels to go. We're taking a very small amount of material off. Typically I work from the top down, but because we want to be able to have the opportunity to measure this, and we probably won't have access to these 2 steps, let's do the deepest one first. You could approach this with pockets, or you could approach this with single line contour cuts. Okay, we're going to do this with a series of contour moves. It allows us to do a finish pass on the vertical wall. You could use a pocket command, but you're still going to have to come back and do a finish on the wall. So we're going to go to 2D, 2D contour. Okay. We're going to select in library our 1/2 inch end mill. Okay, and we're going to leave the default settings for feeds and speeds. We'll go to geometry, and we're going to select the first deepest step. We're going to go to heights. We're going to leave all this at default. Under passes, we're going to want wear compensation. In this case, we don't need any roughing passes in Z, but on the sides we do, because right now it's just going to cut a 1/2 inch swath through here. So we're going to do roughing passes, and then we have to tell it a maximum step over, which let's go 400 thousandths, which is 80% of the diameter of the cutter. And to calculate the number of step overs, it's our maximum step over divided by the distance we need to clear out. So if we look at our drawing, that final step is 236 thousandths 5/10 from this edge. If we subtract that number from 4 inches, which is our overall part length, so let's do that. Our part is 4 inches long minus 2.365. That gives us 1 inch 635 thousandths. And if we were to divide that by 0.4, that would give us 4 passes for full cleanup. Okay, so on that step, let's put 4. We'll go to the next tab. We're going to do horizontal lead-in radius we don't want. Put that at 0. We're going to come in at a sweep angle of 0, and because we're going to come in off the workpiece. And our linear lead-in distance is going to be 0.06. That's, I'm sorry, 0.6. 0.6, that's that way it comes off and we can see as it's approaching. Make sure we're not hitting anything. We're cutting the deepest depth first, so if we have a problem, we're going to see it on that first cut. We're going to have a lead in, lead out with 0 vertical lead in, and let's go and hit OK. And we get 1, 2, 3, 4 rough passes with a finish pass. Okay, so if we're to plan for our next one, we can just simply duplicate this operation, but we're going to go a shorter distance. So let's plan ahead and let's measure the distance of this next step. It is only 375 thousandths. Okay, so if we go to this one, we go to edit, and the only thing we need to change is on that passes tab. To do less than 400 thousandths, we just need one rough pass and then allow it to have a finish pass. Then we're going to go to geometry and we're going to clear out what we've selected, and you're going to select the next step and we'll hit OK. Alright, so that's our next step, and then we're going to follow suit on this third one. Okay, so we're going to right click on our operation and we're going to say duplicate. Before we edit that operation, we're going to inspect the length of this next pad. So it's 0.990. So if we take our calculator and go 0.99 divided by 0.4, which is 400 thousandths, we need to do 2.5 steps to do full cleanup. Okay, so we're going to do 3. So edit. We'll go to geometry, clear the selections, select our new edge. We're going to go to heights, we're going to leave all that default, go to passes, and we're going to do 3 step overs instead of 1. Linking tab, hit OK, and there's all our roughing cuts. Again, this gives you an opportunity to stop the machine, measure this thickness. You could put in, when you use optional stop, it'll stop at the next tool change anyway. Then you can proceed if the model looks good, or I'm sorry, if the part measures good. All right, now we're going to go, and the next step would be to cut this pocket. Now, if we look at the corner of this pocket, let's inspect it. It's 180 thousandths. If we go in with a 3/8 cutter, that will leave, that'll barely cut this, because half the diameter, the radius of the cutter, is 375 divided by 2, which would be 1785. So this fillet is really what would be left by a 3/8 end mill. Okay, so we're going to close that window. So the smallest cutter, the biggest cutter we can use is a 3/8 end mill to cut this. We're going to go to 2D, we're going to use pocket, and we're going to select from our aluminum library the 3/8 end mill. Now you could use a quarter, we've already used it, it'd be one less tool to set up, but this one will remove material faster on the operation we're doing. So we're going to select the 3/8 end mill, and then we're going to skip the multi-axis tab and go to geometry. Now typically I try to select the bottom of the feature. In this case it's not the full pocket, so we're going to pick the top and make sure the arrow's on the inside. But on our heights tab, instead of going to selected contours, we need to go to selection and select the floor of our pocket, and that'll give us the proper depth. Okay, we're going to go to passes. We are not going to leave stock to leave. We're going to do multiple depths. We'll leave the, we're going to put the roughing step down at 0.25. We're going to do 1 finishing step down on the bottom. We're going to leave 10 thousandths for that step down. Use these in step downs, order of depth, and then we're going to do finish passes. I do this instead of doing 2 routines. It seems a default to leaving a bunch of material with a pocket and you come with a different cutter, but we're going to use wear compensation, and we're going to do 1 finishing pass. Our step over here, and our finishing, we're going to go 0.02. Okay. So that in effect does the same thing as doing a pocket and then a contour after to clean it up. So, and we want to make sure that down here at the end, the stock to leave is not selected there. Okay. We're going to go to linking tab. We're going to leave this stuff at default. The vertical lead-in radius we're going to set at 0. We can plunge by helix or ramp. If we do helix, you can do plunge straight down. With aluminum and aluminum cutters, you can do that. We'll go ahead and do a helix. It'll come in nice and slow. But we want to set this ramp clearance. We want to set that at 50 thousandths. And that will spiral before it hits the part in air. If that's really high, it sits there and makes lots of spirals, and then it's just wasting time. And let's hit OK. All right. So we spiral in. We do a rough cut, a series of rough cuts, and then on our outside edge, we're doing a finish cut at the end. Okay, we're done with the pocket. Last operation's holes. We're going to cut all 8 holes with the 246 drill. The 246 will be on the edge of the tolerance for this outer pattern, but we can always go back in with a 1/4 inch or ream if we have to. But because the tolerance is fairly loose on them, we're going to use 246 there, and it'll be smaller than both these holes here. So let's start with our spot drilling. So we're going to go to the drilling tab. We're going to select from the aluminum library. Make sure your milling checkbox is selected, because we're actually using the 3/8 chamfer mill. Have to put in manual numbers because we didn't. This is just for center drilling. So we're going to select our 8 holes. And instead of taking the default, we don't want to plow all the way through our part. We're going to go to Heights tab, and we're going to go from hole top to hole top, okay, which technically is no depth at the moment. And then we want to put a depth in that will just give a very slight edge break on these holes. So our largest hole is a 251. So if we want a 5 thousandths edge break, just what our deburring would do, we would take our largest hole, which is going to be the 251 to 252 that's on this step here. Okay, so we're going to start with the largest that hole can be, it's 252. And then we're going to add 5 thousandths per side for an edge break. So it'd be plus 0.01, 10 thousandths. Okay, that gives us a 262 diameter edge break divided by 2. And the math works out with a 90-degree cutter. That's the depth we would need to go through to achieve that. So we're going to put in a negative offset of 131 thousandths. And so on these smaller holes, you're going to have a slightly bigger edge break, but they'll be fairly consistent. The main reason we're doing this is to spot drill the center so that the drill bit goes centered. The fact that we're breaking the edge on that is a bonus. It cuts down on our finish work. I've had a couple students ask why we're not cutting chamfers all the way around the edges and deburring it. Some places will do that. Typically places that are making their own product and want to have as little finish work as possible. Most of your job shops are not going to bother. You're going to throw it in a tumbler. So we hopefully in this class will have the opportunity to put your parts in a tumbler, and you'll see how it deburrs the edges very quickly, and you can keep your machine running cutting parts. Okay, and we're going to hit OK. We're going to go to the next tab, and we're going to do our deep drilling with full retract, and we're going to change this to 060 steps, and we're going to dwell for 1 second at the bottom. All right, let's hit OK. And it should go down and cut relative to the height of each one. Okay, next operation, drilling. So we're going to go to drill, and we're going to select from our document list that we made. we're going to pick the 246 drill that we created. Select that drill, and we're going to hit all the same holes. Okay, and then we're going to go to the Heights tab. And I'm looking at the part from the side because you can see how deep it goes by default. So it's not drilling all the way through. What we want to do is break through with tip, and then we want to add 10 thousandths. That'll make sure that drill bit goes all the way. Actually, for good measure, let's do 30. We're not sure that if you're not sure on the drill tip geometry, it's better to go a little deeper. I think the high performance drills have a different angle on them than the standard old school drill bits. Okay, and so you should be able to take the defaults top to bottom. It'll do relative to the height of the hole. Let's go to our cycles. We're going to go our deep drilling cycle, and we'll just leave the peck depth at default, and okay. Alright, so now we've drilled all 8 holes. Now we need to come back with a reamer for these two and a different reamer for these two. And it's critical you load the right one in the machine, because you put them in the wrong order and you're going to have a discrepant part. Okay, so we're going to use the drilling command. Now we're going to select tool 17, which is the 249 reamer. And we're only doing these 2 holes with that reamer. Okay, and we're going to go to the Heights tab. You're going to leave everything at default except for we want to break through at the bottom as well. Now a reamer doesn't really have a point to it, but we're going to go, but it does have a chamfer on the tip, so if you don't go past, it's not going to ream to the right size. So we're actually going to go 0.06. We're going to go 60 thousandths deeper. That makes sure it clears the other side of the hole, pushes any burr out. On our cycles, we're just going to use the reaming cycle and hit OK. Now we're going to go to drilling again. We're going to select tool 18, and we're only reaming these 2 holes with this reamer. That brings them to size. We're going to go to heights, same thing. We're going to break through bottom, and we're going to go negative 60 thousandths, so we make sure we go through. And our cycle's reaming, so hit OK. Oops. Sorry, under the breakthrough depth, it's not negative. I hit a negative symbol by accident. But that's, if you're using the breakthrough field, it's a positive number. If you use offset, it's negative. It's kind of interesting there. And let's hit OK. Alright, we're done. We've programmed everything. Now you need to post-process and make setup sheets for each of these. So again, you want to get your screen set up for the operation you're doing. So let's just do an example on this one. You have multiple flips. You need to communicate this to your operators or whoever's setting this up. Okay, so if I were to look at setup 1, I would make the vise visible for setup 1. I would highlight the toolpath. You hit the radio button for setup 1. Rotate this into a view where you can see the origin. Okay, zoom way in, because when the setup sheet is created, this view zooms out a little bit on the setup sheet. Okay, so we want this origin to look visible. In fact, let's let's so the default display on here is all in color. I'm not so sure that the shading adds much. It's really hard to see the origin. So let's try this. We're going to go to Visual Style and we're going to do wireframe with visible edges only. And it makes everything a more subdued color. And this will allow a better illustrative graphic, I think. And the X, Y, and Z coordinate gnome will show up better. So let's give that a shot. And we're going to go to Setup Sheet. You need to pick a place where you're going to put it so that you can print it when you get to the lab. So select the folder you want it to go in. But you want to be able to see in this view. You want to make the best setup documentation you can. Okay, so, and again, you're going to need to change the name of your document each time where you're going to overwrite it. So in this case, there's only one tool. So when you go to save this off, make sure the correct program number shows up there with the correct setup. And then you need to go to the next, then you need to post-process it as well. So again, you're going to have that highlighted and you're going to hit post-process. You're going to need to pick where you're going to put it. Make sure your information is correct. You need next generation control for the mill. And hit post-process and you should get a message down at the bottom there. You need to do that. Repeat those steps for all three of these setups. I'm not going to walk you through each one, so rewind this video if you need practice on that. Okay, when you're done, you can return your visual style to shaded with visible edges only, and it'll return to the fully shaded. That's a suggestion. The fully rendering works, but it looks like to me it's a little easier to see the origin and highlight what's the part if you go to the other settings. So there we go. We have concluded the programming tutorial for 99999-101 Rev 2.